Hello everyone, welcome to my YouTube channel Bionic Bee. This is the third part of the genetic algorithm root optimization video. So if you remember, in the last video we have extracted the location details. So we ran this code, we got extracted the location details, and then in this part we will be running the genetic algorithm and try to understand that. So this is the interactive cell, we have enabled it, then we have imported all the useful packages. In this case the most important package is going to be deap. So deap is the module what is going to help us in running the genetic algorithm. Then we are reading the location file what we got from the previous notebook file, and we are filtering this file for the state only Karnataka, and it is because I have collected the data from web, and there is a chance that the longitude and latitude information what we get might not be correct, right? So that's why we are just filtering it. In your use case you can do the data filtration accordingly. We are dropping the duplicate values. If in case there is any duplicate possible, we are dropping them, and after that we are doing a reset index. Now the most important part in this case is that we have two optimization objectives are there. One, minimizing the distance travel and maximizing the rating. But if you look at the rating here, this place has given a rating 5 out of 5, but the total number of rating is given 81. And in other case, the second place is given 4.5 rating, but the total number of people who was given the rating is 514. Keeping this in mind, I wanted to create a mathematical function such that it takes rating and popularity and gives us a number which is combining them together, right? So I have done this specific mathematical function, and here we have rating as a matrix. Now I plot the rating in a histogram, and I plot the rating in a distribution plot, and this is how the results look like. Then after that, if we make a sample, then our data looks absolutely fine. We have all the details what we need. We have the rating as a matrix, popularity, latitude, longitude, state, and popularity is not needed as of now, because now the rating what we have is actually the function which is creating the rating is also considering popularity as a part. Now from here we are trying to do plotting, different kind of plotting. So I plotted all the location what we had in our case. So if I show you the location details, so this is highlighting the location. We are not able to do this is not able to show the exact mark, but we have these marks in the specific location. Maybe the browser is not supporting the exact landmark details, but you can see the square box created in that specific location is the location details what we have, and these are the ratings what we have given, right? So now what we are going to do is we are going to create our genetic algorithm tool, and we have the first thing which is known as creator. If you do not understand the terminology, I suggest you to go back to the video, the first video what I have uploaded in the genetic algorithm series, and there I have explained about all these terminology related to the genetic algorithm. You can watch that video, and probably after that you can come back. So this part here, we are creating a fitness multifunction where weights, we have two weights. This is really an important part where -1 defines minimization of a problem statement and 1 defines maximization. So in this case we are minimizing the distance and maximizing the rating. And we have a fitness a creator in this case, which is going to create different individuals, and individuals means different weights in our case. We have toolbox, which is going to have all the tools inside for the genetic algorithm. Now the number of places in our case is going to be 7. So I have just taken a random number. You can take n number of places in your case. Just to keep in mind, if you increase the number of places, then the number of weights what we are going to generate is also going to increase. Now we are registering the index. Index is going nothing but the places index, the index of the places what we have created in the data frame. So I'm registering that, and I'm creating a random choice. So it's gonna from the starting of the data frame to the end of the data frame with the n number of place. So it's gonna choose randomly 7 different places, and it's gonna choose it by the index number. That is what I'm defining in this case. So here I'm doing 7 places. Now the tool works. I have individual and I have population. Population is basically the whole set of weights what the genetic algorithm is going to generate to create its to create different individuals. So if I just wanted to see one of the individual, I have printed here one of the individual. Now we have the evaluation function. Objective function is total distance minimization, and the objective function 2 is going to be total score maximization, right? So create tour function is going to take the longitude and latitude information for the different individuals, and it's going to return that information to us. So you can see if I send this individual, as I said, this individual is nothing but the index. So I should have all these data points. If I just pass on those index, it's gonna give me all the longitude and latitude information. Then using this information, I can calculate the total distance. So what I can do is I have created a total distance function over here, which can take this store information, and it will take longitude and latitude and calculate the distance, and it is going to give me the distance function as it is, right? The total distance. Then we are calculating the distance between place. Just keep in mind, the first function is only taking that specific place as a parameter, the longitude and latitude, and the second function is considering 2 different places and try to find out the distance between 2 different places, right? So yeah, then we have all this mathematical function calculation, which is going to give return as a complete distance. For example, if I calculate the total distance covered by the tour, what I have given is going to be 135 in this case. So this function is returning all those details in this case. Now if I plot this tour, I can see we have those landmarks, and I have this blue line showing the graph. It depends on where you are starting your location, where we are starting with. You can go anyway. This is a randomly created graph. So this is the graph what it's saying. This is the location where we can travel, but you can see this is not optimized as of now. These are not the 7 places what we have, because I see a bigger cluster in Bengaluru area, so that can be one of the good cluster. Yeah, so now sorting the output, I'm just creating the rating, the total score, and I'm yeah, I just wanted to see how much overall rating I'm getting out of this, and I'm returning those value. I'm just creating a sum of rating. You can create different mathematical function, just like you wanted to create the mean rating as the maximizing the mean of all the places rating, that you can do, or maybe you can create different mathematical function. It's just your creativity how you can create different mathematical function to understand to let the model know about the rating. Now the evaluation function is going to be really important. In this case, it's going to take the individual, it's going to calculate the distance, it's going to get the total score what we have. So as I said, the distance is going to be minimization and the score is going to be maximization. Score is nothing but the rating, overall rating. So we wanted to get the overall rating as maximized. Then I'm creating some mathematical function and I'm returning the total distance and the total score what we have. So you remember the first place we have 2 weights create. One is -1 and one is +1. So these are the 2 weights. The first one is -1, so it is minimization, and the second one is +1. It means it's maximization. As I said, the distance is minimization and the score is maximization. We really need to understand or keep this in mind when we are coding this. Now we have to register all the tools what we have created. So we are registering the evaluation function, the selection, the mating, and the mutation function in this case with different parameters. You can use different selection tool if you want, but before that, just go to the deap website and read about this tool so that you can understand in more details. Now, so these are some basic default parameter what I have selected for the model selection part. So the population size here in this case I am taking as 200. The maximum generation what we are creating as 100. The mutation probability is like 20%, and the cross section probability is 80% in this case. So the toolbox is creating a population of the population size, which is going to be 200. Just to keep in mind, more the number of population, more the number of data points it's going to create, and if you increase the number of population, it's going to be difficult for the model to find a best individual for the result. Okay, this is our population in this case. Now we have HOF. HOF is nothing but Hall of Fame, and we have Pareto front. In this case, you can read about it in the genetic algorithm website. And we have the starts registered, and this statistics we are getting for the weights what we are generating for the genetic algorithm. And to understand it, we are trying to get the weight of average, mean, average, minimum, and maximum. Now the algorithm what I'm using to run the model is going to be AE mu plus lambda. There are different 2 to 3 different algorithms what we have. Based on the scenario, you can do experiment and you can find out which algorithm to work for what kind of problem. So for this problem, I found this algorithm to be the best one, and I have all the parameters already defined. Then I have create verbose equal to true, so that I can see all the logs. Right. So after running this model for 100 iterations, Hall of Fame is going to store all the results, all the best results, or all the best generations what it got by looking at the evaluation function. So that is how I'm just looking at the first Hall of Fame, the first result, and it says the first result which is best for the model is this one. Also, you can use this tool which can find out the best result from the whole set of population. In this tool, once I ran it, it also gave me the same result. So it means the result what we got is almost correct. Right. So now I ran it for the 100 iteration. If you can run it for more iterations, it might converge at some point in time, but the result might also get improved. So it is always an optimization. It is always a trade-off between the number of iterations you run and the chances of getting over fit. So you have to take care of those things by experimenting it. So if I look at this set of population, remember this is nothing but the index number or data frame. So I am plotting all the index numbers. So if I plot all the index number, this is the place what I'm getting as the optimized place, and I have 7 places. This is their rating, this is their popularity. Popularity is not in use, their longitude, latitude information, and all the details. Now if we plot those details here, I'll just zoom in a little bit. Yeah, we can see this is the path which is having the maximum rating and the minimum distance covered by the model. Now the best individuals, I have all the individuals plotted here. I have all the things shown here. So yeah, this is exactly what you can find out the best route by using genetic algorithm. Also, you can take the same technique and apply it in other cases. For example, finding best movie which is available online with less money and higher rating. You can apply those concepts. You can use the same technique to optimize your model output and results. Maybe I can create one more video. Please comment below if you wanted to see more kind of use cases using genetic algorithm. This is one of the best technique what we can have to do any kind of optimization problem. I'll be uploading those codes to the GitHub link. You can download it from there, and if there is any concern or any questions, put it in the comment box so that I'll personally go to the comment box and read and try to answer all of the questions what we have. So thank you so much for watching this video. Have a good day and subscribe to my channel. Bye bye.